Okay guys, this is it. This is our last lesson. It's going to be similar to the last one, but on the last one we would just have multiplied negative square root of 5 times 2. But on this one we're going to do the distributive property where we multiply negative square root of 5 times 2 and times square root of 3. Okay, so talking about this, we can't put a square root of 5 together with a 2 because they're two totally different numbers. Remember that? And if you see a negative here, you might want to put a 1, so it will remind you that that's really a negative 1 times 2. So it's going to be negative 2 square root of 5, and then the square root of 5 times the square root of 3 is plus the square root of 15. Now, you can't be through with this problem until you won't be through with this problem until you check the radicals and make sure they're in simplest form, the square roots. This one we know is in simplest form because 4 doesn't go into this, 9 doesn't go into this. We know this is in simplest form because 4, 9, 16, none of those go into that. So you're through, and it's that simple. This is probably going to be the simplest page you do, but a few of the problems on IXL can be difficult, but I really think you can get through them. On this problem, we're going to multiply the 8 times the 9 because we can do that. A number times a number, we can do that. That's 72. But there's not a radical here with the 9 to multiply by the square root of 11, so we just write it down. And then we're going to do 8 square roots of 11 times 6 square roots of 3, where we can multiply the 8 times the 6 and the radical 11 times the radical 3. So it's going to be plus 48 radical 33. And we just have to check these. 11 is... basically it's prime, so you know it's not going to break down any further. Think about it that way. Think about the numbers that you could think about. Instead of saying 4 won't go into this, 9 won't go into this, 16 won't go into this, 25 won't go into this, 36 won't go into this. So we know this is simplified. You can think about, what's the only thing I can multiply to get 11? 1 and 11. So those aren't pairs, so you know that's in simplest form. What can I multiply to get 33? Well, 3 times 11, if you think about the factor tree. 3 times 11, well, those aren't pairs, so they can't come out, so this is in simplest form. Okay, so that's your answer. One lesson that we skipped is that we can't combine these together when it's a plus or a minus. We can't combine these, just like we can't combine these, because they don't have the same square root. It would be like trying to combine this. You would never combine minus 2x plus y. You would never combine this. Let me write this note. You would never put this together because they are not like terms. This is what you would have told me in class. So then I would have went back and said, well, these aren't like terms either. A square root of 5 and a square root of 15 aren't like terms. A square root of 11 and a square root of 33, they're not like terms. Okay? Why are you saying this, Ms. Wright? Because we're not doing a lesson on this. But within this lesson, I think I had 1 or 2 come up on the IXL, and you'll miss the problem if you don't know that. Okay? The next 3 are going to be using the full method. So it's going to be first times first, which is a negative 45, because we can actually multiply those. And then it's first times, remember it's like this. And then you take the negative 2 radical 5 and you multiply it like this. Okay, so it's negative 5 times 9, which is negative 45. It's negative 5 times a radical 21, so you just put those beside each other. Those cannot even multiply together, which I kind of like because it doesn't give me a big number. Then you do negative 2 times 9, which is a negative 18 radical 5. Okay, and then you do negative 2 times, there's not anything here, it's understood to be a 1, so it's a negative 2. And then square root of 5 times the square root of 21 is going to be the square root of 5 20s is 105 ones, so it's the square root of 105. All right, now you have to check these. This is like 3 times 7, and those don't match, so you know that's in simplest form. That 5 is 1 times 5, so you know that's in simplest form. 105, how can you check that? Well, you could go back and say that this is 1 times 5 and that this would be 3 times 7. Does 1, 5, 3, or 7, do any of those match? No. So that's how you know that this is in simplest form. And this is a horrible looking answer. I know you're thinking there's no way that can be the answer, but it is, and you have to put the answer in like that. None of these will go together because they're not like terms. They're in simplest form, but they're not like terms. All right, so let's go to the next one. So we've got 8 times 6, which is going to be 48. We have got 8 times 6, 8 times negative square root of 11, so it's a minus 8. We can put a 1 there. That makes you feel better, okay? 8 times negative 1 is negative 8, square root of 11. Then we've got 6 times a negative 1, which is a minus 6 square roots of 11. And then we've got negative 1 times negative 1, which would be a plus 1. We don't have to write that. And then the square root of 11 times the square root of 11, do you remember that that's going to be the square root of 21, which is just 11? That's just plain old 11. Remember, any square root times itself gives you the number that's under the radical sign, the radicand, whatever number's in the radicand. All right, so if you look at this, there's a lot of stuff going on here. You've got this whole number 48 and this whole number 11. Well, you can put those together. So let's organize this. 48 plus 11, and then I've got minus 8 radical 11 and minus 6 radical 11. We can put these two together, and believe it or not, this time we can put these two together. Why? Because these are the same kind. They are like terms. They're both radical 11s. So this is going to be 48 plus 11, which is going to be 48 plus 1 is 49, plus 10, doing place value, is going to be 59. And then this is going to be a negative 8 and a negative 6, so that's a minus 14 radical 11. Now, it's not going to matter which way you put this in. A 59 minus 14 radical 11 is a good answer. If you put in 14, make it negative, or 14 radical 11, make it negative, and then add 59, that's going to be the same answer, okay? All right, last one. So first times first, look at this. We've got a radical 91 times a radical 91. So that's going to be 7 times negative 1, which is a negative 7, and it's going to be times 91, okay? Or if you want to look at it this way, it's times radical 91 times 91, which means you can pull that 91 out, okay? Might be easier to look at it that way. So that's multiplying this. When you multiply 7 times radical 91 times radical 65, you might not want to multiply those together because remember it makes a really big number. So just hold on to that thought a second. Then you're going to multiply a negative 7 times a negative 1, which is a plus 7 radical 39. And if you want to put them under the same radical sign, you could, times 91. And then you've got negative 7 radical 39 times radical 65. Now, we took care of the first one, but we want to talk about these other ones. You don't want to multiply these together. It's going to give you too big of a number, okay? So what you want to do is try to break these down. And 91, I know that's a tricky one, but 91 is divisible, I think, by 13. So we're just looking for any numbers, okay? We're not looking for, we're looking for any numbers. We're not trying to divide by 4 and 9, unless you want to do it that way, and you're welcome to do it that way, okay? But, so I want to say 91 divided by 13. Yes. All right, so this is going to be, and I should have done this. This is going to be, let's see, I did 7 square root times this, and then I did 7 square root of 9 times, yes. Okay, so this should have been a plus, and I didn't put my sign there, sorry. All right, so plus 7, and under this square root of sign, we're going to have 13 times 7, that's what this breaks into, and those are prime, and then 65 breaks into 13 times 5, okay? This was actually a problem that came up when I was working it. All right, so we've got a pair of 13s, so when we do this, we've got negative 7 times 91 right here, we've got 7 times 13 times radical 35, because those can go back together, okay? Plus 7, and 39 is going to be 3 times 13. We know that 91 is 13 times 7, okay? So we've got another pair of 13s. So we're going to say 7 times 13. 3 and 7 don't match, so they have to go back together and stay under the radical sign. And then we have minus 7, and we know that 39 is 3 times 13. I just happen to know that one. And then 65, I happen to know that one, is 13 times 5. So we've got another pair of 13s, which is minus 7 times 13, and we've got to put the 3 and the 5 back together. Now, look at these. You've got radical 35, you've got radical 21, and radical 15. None of those are going to go together, but you've got to do all this multiplying. So we just take our calculator, and we want to say 7 times 91, and I know it's going to be negative. Okay, let me make sure. 7 times 91, yes. So we've got 637, it's negative. We got 7 times 13, which is 91, so plus 91 radical 35. We've got 7 times 13 again, which is plus 91 radical 21. Now those aren't like terms because of the radicals aren't the same. We don't care about the coefficients in front. And then minus 91 radical 15. And that is your ugly answer, okay?